This conference will now be recorded.
Okay, so good evening, everyone, and welcome back to the fresh new session of the credit risk modeling workshop. And today is day three. We were discussing about reject inferencing and the marginal accepts approach, right? Now, so basically, what we'll do is we'll start off by talking about the concepts of the concept that we discussed yesterday, right? So the basic discussion that we had yesterday was we looked into the data flow or the population flow for application scorecard, right? So from the through the door population, how does it get divided into completed and incomplete applications, incomplete or pending applications, and then with the completed base, you have the accepted and the rejected base. Now, within the accepted base, we have the known good bad population. Now, within the known good bad population, the challenge of developing only a model using the known good bad population is that we are developing the model using only the accepted application. The rejected applications do not find a way into this part. So that is the reason why we cannot use only the accepted good bad population base. And what we could do over here is what we need to do over here is we also need to incorporate the rejected base, right? The rejected base, and the entire idea behind this incorporating the rejected base is to incorporate the score declines and the policy declines, right? So that the rejected population can be incorporated. Now, the problem over here is for the incorporated rejected population, you do not have this. So you do not have the observed good and the observed bad decisions, right? Now, given that you do not have the observed good and the observed bad decisions, so the next question that comes out to us over here is that what is the way through which we can identify that observed goods and the observed bads, right? The way in which we can identify the observed goods and the observed bads is the reject inferencing approach. Now, the question that comes out over here is that how reliable is it to score a rejected base of accounts with a model developed on the accepted base, considering the fact that the profile of the two groups of the borrowers would be very different. So there is always expected to be an inherent bias in the reject inferencing process. So the question that comes out over here is that how is it that we can do this? So over here, the entire idea that we look in, right? So the entire thing that we look into over here is that so the first question that we try to understand is that how is it that the accepted and the rejected base can be aligned to each other so that this extent of bias in the reject inference exercise is reduced, right? So this is where the second question comes. So the question that I have over here is that how reliable is it to score a rejected base of account with a model developing the accepted base? And then the idea is yes, it is reliable, but the population in the accepted base has to be aligned to that in the rejected base, right? And when we do that, so and how do we do that? We talked about the marginal accepts approach for doing this exercise, right? So so we talked about the marginal accepts approach and how is it that the marginal accepts approach is executed, right? So over here in yesterday's discussion we had created this table. We went through to create the marginal weights and we saw that as at the lowest bureau score decides, right? At the lowest bureau score decides, there are certain accepts and certain rejects. And as the decides progress to the higher score, there are certain number of accepts and there are certain number of rejects, right? Now, in the lowest score decides, there are very low volumes of accepts and very high volumes of rejects. And at the highest score, there are very high volumes of accepts and very low volumes of rejects, right? So now the question that arises over here is that how do I weight these accounts which is in the lowest score bracket? So do that, what we do is we multiply, we divide, we create the ratio by dividing the accepts to the rejects. So the total volume of accept rejects divided by the total volume of accepts. So at the lowest score decides. So at the score decides, the worst score decides, the worst of score decides, you would get to see that there are smaller number of accepts and the number of rejects are much higher. Hence, what you would always get is a higher, so you get a higher marginal weight, right? So the impact of this marginal weight is to score each of those records such that, or is to assign a weight to each of these records such that the importance of this record would be boosted, right? So would get impacted, right? So this is the weighted record. So what is the weighted record that you have over there? So the weighted record that I have over here is like 32.33. So that is the marginal weights, right? So now when you have the marginal weight, so there are a total of 100 records, and in this 100 records the marginal weight is equivalent to, so basically 32.33 into 100. So each of these 100 records get impacted by the this 32.33, right? Now, similarly, what we would expect to see over here is that that for each of these records, sorry, the accepts are weighted by these marginal records, right? Because it does not impact the rejects. So one thing that you see is the moment I multiply this marginal weight to the accepts, right? That that value will replicate the value of the rejects. So the number of accepts over here, so you are, in terms of the number of records, you are making this section to replicate the records in the rejects, right? So so over here now, what is the importance of this analysis? So why is it that we are doing a marginal accepts analysis, and why are we building a scorecard at all? Now, is there a requirement to build a scorecard? So how do you identify that? Now let's say at the lowest score, bureau score, so there are two things over here. First is that the deciling is being done according to the bureau score, but the accepts and the rejects in the historical data has been done basis the behavior scorecard, which is already in production, right? So let's say there is a scorecard which was built historically. So for corresponding, so that scorecard has kind of distinguished between accepts and rejects. And out of the total accept which has been done, we see that there are three such accepts whose bureau score was very low, right? So one thing you can clearly make out is that these three accepts are now nothing but they might be the marginal accepts, right? So they marginally there, the score cutoffs may have put them in the acceptance zone and their credit was approved. However, these borrowers on basis of the general bureau score, you can see that they have very low bureau score. So what it means is that the general credit history of this borrower is not that impressive. It may be that his performance in terms of the very specific variable which the internal scorecard has been using for that particular portfolio was relatively stronger, and hence he just made it through. So these three accepts that you can see at the lowest score decides are nothing but your marginal accepts, right? Now similarly, as you come across the highest score decides, the top two score decides is 780 to 810, 810 to 850, right? So they are the top 20% of the people, right? And over here you can see that there are three records which have been rejected. Now they may have been rejected because of some reason, but these two profiles of these three rejects that you can see at the higher score bands, it's far better than the account which has been accepted at 5 at the lowest score bureau score bucket. So now the question that comes out over here is that then what happens is then there is a trade-off which is possible in this situation. So it is always possible that I will kind of pull out the 3 records which I had accepted, right? And I will pull in these 3 records which were initially rejected, because I get to see that at a very high bureau score, right? So the score assigned was very high, but it may be because of some specific policy reasons or some or reason or the other, the account was rejected, right? But the rejection is very low. So so one thing that you can clearly see is that even in this, when you have a distribution like this, right? So at the lowest score bucket, there are some accepts, there are some rejects like this. So then you know that there is certain, so there has been certain misclassification, there has been certain adverse selections, right? And therefore you always have a chance to swap in the borrowers, swap in new borrowers and swap out the more risky borrowers. So over here, if you swap out the 3 accepts at 550 to 560, and instead of that you take the 3 records from here, from the rejects, right? So the total number of acceptance or the overall approval rate will remain unchanged, but the probability of the borrower to default or the overall bad rate will kind of go down, right? So this is only possible when the scorecard that I am building has a better capability to distinguish between the good and the bad. So it is more granular in its approach to determine the good and the bad. And hence what I'm saying is that there is a chance of a swapping to happen. So there has been cases. So I can see there is a case where the existed model has not done a very perfect classification. So there is a classification error and there is a scope for business improvement, right? And therefore, what we can say is that yes, what you should do is you should kind of rebuild. So there is a opportunity to build a better scorecard, because there are some accounts which can be swapped out and similar number of records which can be swapped in, but the profiles of those records would be better. So at a given approval rate that you presently have in this distribution suggested by the older model, you can swap in better profiles of borrowers, and then the overall bad rate in your portfolio would go down. So the overall volatility or the overall riskiness in your portfolio will reduce, right? So this is a very important analysis of exactly how the overall model or the overall behavior the model is, right? So as the capability of the model deteriorates, right? So you will see that more number of people are like up there at the lower score decile, lower bureau score decile. So the way the bureau has classified and the way you are exactly your internal score is classifying is not actually aligned to each other. So there is a way through which your this thing can change. So there can be a way through which your uh, so there is a point, there is a gap where the distribution is different. So what you need to see is we need to understand that there is still a scope of the business for the business to improve. So similarly, let's say 11, if I move to the next part. So 560 to 520 is a pretty low amount, but 750 to 780 is a pretty high score, right? So there are 11 accounts which has been rejected. So I can actually swap in these 3 and swap out these 2. So 14 records can be swapped in, is in place of 14 records which could be swapped out, right?
Tanmay,
Yeah.
but there will always be some policy accepts and policy rejects in our scoring model too.
Hmm. Yes, there will be.
Yeah,
So
so
you'll
whatever are
always
the
have, yeah, so you'll always see basically what happens is when you have some important policy rejects. So policy rejects are generally removed out from the base, right? Now the policy rejects some, there are some policy rejects which are excluded. Now there are certain low score overrides, high score overrides which are there, right? So the score was actually high, but because of certain reasons they were not given the loan. So that's the underwriting reasons. So generally what happens is that there are certain cases where some of the, so there are certain basic policy rejects, right? So let's say if a person below 18 years of application applies, he's just removed from the, it's not passed through the process, right? So that's a policy decline. Now there can be many such policy declines. Now some of them make way into this and some of them do not make way, right? So there will be certain exclusion, but even after that, even if it's not a policy exclusion, even if it's a score decline, it could be because of some reason or the other, right? There could be that one particular metric of the person was missing, or one particular metric of the person was kind of was bad, because of his overall score has gone down, but on the whole the overall score was good, but and it's over long term history his bureau score was high. So see, bureau scores give you a generic outlook of how the credit history of the borrower has been. But when you apply for a particular portfolio, there are certain portfolio specific factors which describe whether you are good or not. So that is the reason why, there you may have a high bureau score, but at the point for that given portfolio, that characteristic does not hold and that borrower is rejected. So that is why even at high bureau scores, you can have an internal score reject, right? So there will always be, so basically what I'm trying to tell you is that there will always be a case, always be an opportunity for the business to swipe out some bad accounts and swap in some better accounts, right? Now on the other hand, and more the discriminatory capacity of the model falls, the more will be the access happening towards the lower bureau scores. So that because the discriminatory capacity model is dwindling and the overall portfolio now starts becoming volatile, and that is where, a acquisition scorecard gets redeveloped. And now whether the redevelopment is actually going to, right? So as I was saying, right? So there is uh, so there's always a certain scope of developing the of redeveloping the model, right? So basically what happens is that when the model's discriminatory capacity fails, right, so it kind of assesses some good bad borrowers as good borrowers, and those, and therefore the number of access at the you know at the lower score and starts increasing, and then you know that your portfolio is becoming relatively volatile on the whole, and hence you need to redevelop the scorecard, right? So when you are actually redeveloping the scorecard, right, so that's where, so whether you need to at all develop the scorecard or not, for that you just need to look into the decile distribution and the accept reject distribution, and see whether you can actually swap in some records and swap out some particular records. Now obviously the accounts which were rejected at a high score, high internal scores, right, and accounts which had high bureau scores was because of, maybe because of the fact that one particular factor which was required for the portfolio was missing from that particular account, or had a low score, and because of which the rejection had happened. But on the whole his credit history happens to be good, so he's a relatively better profile than the account marginal accept account, than the account which was accept at the margin, because that account is relatively more volatile and may have defaulted going forward. So had I not taken him, pulled him out and taken these two accounts, then the bad rate in my portfolio may have been relatively lower. So these are some of the challenges that we generally get to see, right? And this marginal accepts table will give me an idea to, will give me a clear picture to show whether there exists any scope of swapping in or swapping out, right? So this is a very critical table, and it gives you the approval rate across deciles and so on, right? So so one thing that you see is that the deciles, the approval rates over here change, but a sharp increase in the approval rate comes in from 720 to 750 onwards, where it suddenly jumps from 41 to 75 at a more than by 35 units, and then from there it goes on to 99%. So basically what we expect is that at the very high brackets it should be like 99 or 99 point some percentile or 100% acceptances, right? But the acceptance percentages are approval rates are a little lower in the worst of score buckets, right? So with this exercise, one thing that we can see is that there is a gap and there is a business opportunity for which we can we can develop the acquisition model. Okay, so Ashwin has a question over here. With the use of marginal weights, will approval rate increase and default rate will decrease? So basically, there are two things to assess the impact of the marginal accept on the final models. So the business impact is captured in terms of two things. Number one is the decline in the bad rate given the approval rate. Number two is an increase in the approval rate given the bad rate. So basically what it says is that the overall approvals in the model must increase if I take the bad rate to be given. So basically, given an amount of bad rate, given a certain percentage of the bad rate, right? So there will be an increase in the approval rate given. So an increase in the approval rate implies that if I'm willing to take the same amount of risk that I had taken, the approval rate will be higher and I'll have a higher receivable on my book. So this model should give me an impact in terms of the approval rate. The second parameter is that if I keep the approval rate constant, this is what I have, this is what I was discussing over here. If I keep the approval rate unchanged in my model across the sites, right? Then what will happen is if I swap in some borrowers and swap out some borrowers, my scorecard must swap out the more risky borrowers and swap in the less risky borrowers. And hence, what I should expect is that the bad rate in the model should go down. So therefore, I would expect a reduction in the bad rate with an increase in the with the approval rate being given, and an increase in the approval rate with the bad rate being given, right? Perfect. So this is also known as so this these two criteria taken together is also known as the swap set analysis, right? And they kind of help you identify the bad rate across, and they help you identify the the riskiness across, and it helps you quantify the business impact. So that's one. Now the next thing that comes out over here is that so I've talked about the marginal accept, and you have seen that the marginal accept is where I'm trying to kind of approximate or align the behavior of this variable to the the dependent variable, right? I mean the behavior of the accepted base to the rejected base, right? Okay. Now the next question that comes out over here is that I just cannot go ahead and do it to a marginal accept. So then what the people are, then what people would generally ask me is, why have you done this marginal accept approach? So you are saying that this is kind of aligning the rejected base to the accepted base. So how do I know that that is what is actually happening? What if you had done without it? How would that be? How would that have been different? Right? So that is where this question actually comes in. So to address that question, we need to develop models both using overall accepts and using marginal accepts, and then simulate the model till the end and see which is the one which gives you the best business impact. Only then can you say that the model that you have developed is a proper model, right? So this is what we plan to do in the next parts. Okay, yeah, fine. So now, kind of having discussed this part, so now we'll go to talk about the modeling side, right? So how is it that the model development would be arranged, or how do we arrange the model development process? So that's something that we will kind of first discuss. Now we will have three phases of this development, right? So the first two phases will comprise of the German bank data. So in the first phase, we will talk about in details, we'll talk about developing end-to-end a KGB model, a known good bad model using the German bank data. And when we are developing this model, we'll first follow the overall accepts approach. The reason is that the first set of models, be it reject inferencing, be it the KGB, or be it the augmented good bad based models that we develop, we need to develop that in respect of the augmented good bad data. In respect of the overall accepts approach. So that is without marginal accepts. So that will be a guys, just give me a moment. Okay. So as I was saying, right, so we'll have three phases of developing the scorecards. In the first phase, we will be talking about, we'll try to understand the end-to-end development stages of a KGB model. So, so how is it that a model on the KGB dataset is to be built up with a target dependent variable, which is a categorical variable. Then what we are going to do is we are going to develop the so after we have kind of develop the KGB model, then we'll bring in the reject inferencing data. Now once we bring in the rejected base, we'll run that model on the rejected base. Now we need to design a method, and there will be a validation approach that we would look through to see whether this result which we have run on the rejected base is in alignment to the expectation, or is there a bias. So how different are the profiles in the rejected base and how different are the profiles in the accepted base is something that we will compare, and we'll do this comparison over the development data, over the validation data, and so on, right? Now after this is done, we'll develop the augmented good bad database using the overall accepts approach, and from there we'll see what the business impact on the final bad rate is. Similarly, we will develop after that the second so after first and second phase is completed, we'll repeat the two phases with the marginal accepts approach, right? And the third phase of the model development will be using the lending club data. So when I say it is using the lending club data, the lending club data is a very famous Kaggle data set, and that data set is a very dirty data. So in the first attempt, when we are using the German bank data, we are just focusing on the steps of model development and how to implement those steps in SAS for our data. But this data set does not have any structural issues like, like missing values, or let's say heterogeneity in the format of the data and so on. So what we are trying to say over here is, that we are going to develop the model on the data, which is, so we are first going to develop it on the data which does not involve too much of data extraction activities, which does not involve performance merging and everything. So the target variable is given, and this data set is ready for development. So I need to understand the steps of development in this data, and the steps of doing reject inferencing, implementing reject inferencing in the German bank data, and developing the augmented good bad base. Now once that is done, the second case study that we have, or the second set of model that we have, which is the behavior scorecard model, it is that model where we will talk about, where we'll see how data extraction is being done, where we will see how is it that the performance definition is getting created and so on. So for that, for the behavior scorecard case study, the model development process will already be known by us, right? So over here, our object focus will be mostly on the steps of developing the model, because the data is fairly simple in terms of structure. But that does not mean that this German bank data does not have data challenges. It has characteristic challenges. So you have to assess so after the data is created, we generally do multiple checks to understand whether the variables are correctly created properly, whether they are properly distributed, and whether they're behaving in a business consistent way or not. So those kind of challenges are there in the German bank data, but extraction issues, but data preparation issues will not be involved at this stage, right? So the first phase one, and in the first phase one, we see the steps of developing the data. Phase two, we see reject inference, the steps of performing a proper reject inferencing. And in phase three, we bring in the lending club data, which has different data structure issues, data preparational issues, and we see how to prepare the data and go and build the acquisition model over there again. So these are some of the questions that we need to understand. So these are three phases in which the application model would be developed. So we will be developing two sets of two application scorecard models and one behavior scorecard model as a part of this. So as a part of this scorecard development workshop, right? So is the approach that we are going to take, is that approach clear to us? Great. Right. So we'll next start off with, so basically we'll first start off with phase one. We'll start off with phase one. So in phase one, our objective will be to understand the end-to-end model development stages of a KGB model, or known good bad model. First, using the overall accepts approach. So basically, we will not be looking into the marginal accepts right at this stage. First, the model using the overall accepts will be developed, and we'll run the entire exercise up to phase two, and then we will develop it using a marginal accepts approach. So let me put it this way: the overall accepts approach of developing an acquisition scorecard will act as a benchmark approach, right? So it will act as a benchmark approach of as a benchmark or a baseline approach, right? So you can use as a baseline approach, right? Now, the KGB model development can be will be replicated in the marginal acceptance. Marginal accepts approach will be accepted, approved, if it provides significantly higher business impacts than the overall accepts, right? Then the overall accepts approach, right? So the next question that we come over here, so then the next question that comes over here is that when we are developing this model, there are certain assumptions, right? So what are the assumptions that we are making? The first thing is I'm not considering the reject inferencing approach at this stage. So it means that the data that I have is only or let me put it like this, the rejected applicants are out of scope. This model is developed on the accepted base. So this model is kind of developed on the accepted base. Now the data extraction exercises is out of scope for this phase of the model development. Model development. The only thing, only focus here is on the key steps of model development, right? So the only focus that we have over here is on the key steps of the model development. And what is the data set that we are using over here? The data set that we are using over here is the famous Kaggle data, right? Though the data is simply relatively simple in structure, the business characteristics, so it has very core business characteristics, right, of a loans portfolio, and it has certain underlying data challenges also, which leads to a prominent and that kind of help us, that can lead to prominently of kind of brainstorming. So so one of the important scope that we have over here is so one of the important thing that we have over here is that we will actually get to study, we will actually get to see a proper business portfolio, right? So even though it doesn't really seem clear to be here, but so this data set is kind of it's much of an underplayed data set. Okay, so now over here, yeah, so we have kind of talked about both the overall accepts approach, marginal accept approach, and so on. So first we'll start off with this step one or this phase one. The second one that we have over here is we have the model development framework of application scorecard using the German bank data. Okay, so now over here we are looking into the model development framework, right? So when I say the framework, I'm looking into the types of the the branches that the model will have. And when I look into these branches, what I'm also trying to find out is that so how is it that this so basically what I'm also trying to find out over here is that how is it that you know uh, the number of models in this situation will stem out. How many models are we going to have? Are we going to have n number of models, or we are going to have segmented model? How is it actually spanning out there? So the first thing that comes out here is that application scorecard German bank data, and the first thing is that the overall accepts approach or the marginal accept approach. Now I want to develop a KGB model, right? So let's put it like this. Just change this framework a little bit. Yeah. Now over here, when I talk about developing this overall, so one thing that we also need to see over here is that what are the other ways. So over here, both these two steps would have the following. Design. Over here, what we have is it is like develop the known good bad model. Known good bad model. Right. So so the first step is to develop the known good bad model, or as I would say, the KGB model. Develop the KGB model. Right. So similarly over here also, if I take this, it will have the same thing. So develop the KGB model. Now, after I have done the KGB model, the next question that comes out here is, develop the reject inferencing model. The reject inferencing approach. Right. And within the reject inferencing approach, so basically next step is what we do is we do the reject inferencing approach. And when I talk about the reject inferencing approach, what we are trying to do is we are trying to understand that how is it that the right. So this is the reject inferencing approach, or let's call it reject inferencing. Now comes the next part. Now, after reject inferencing will be your accepted, your augmented good bad data. And the third that you have over here is your augmented good bad data. This is known as the augmented good bad data. Okay, fine. Just give me a minute, guys. I'll just be back. Okay. So now this is something which is valid both for, you know, the marginal accepts definition and the overall accepts. So I'm not kind of expanding the marginal accepts at this point of time. Okay. Right. So the marginal accepts will follow exactly the same kind of a framework. Now, what are the different ways, in which the model can arise over here? So this is one set of your model, and this will be another set of your model. And then what you do is you do a comparison of the overall accepts approach versus the marginal accept approach. So there will be this. Which is the versus approach, right? This is the overall accept approach versus the marginal accept approach. Now, when you are developing a known good bad model, so what are the things that can happen over here? Okay. Hmm. Okay. So now, when I want to develop a model on this known good bad model, right? When I want to develop a known good bad model, then what are the different kind of variations that I will get?
Hello, Tanmay. Hello.
Yeah.
I just Yeah, conclude with this. This overall accept is develop known good bad model. That's fine. Reject inferencing is on the accepts plus the rejects.
Right, right. So we need to
So
do the reject inferencing both for the overall accepts approach and for the marginal accept approach, right? So basically, when you are developing before you develop the final scorecard, what you will get is a set of these three models. And for each of these models, there will be different submodels. Now, when I say submodels, what do I mean? The first question that comes out to you when you start developing a model is that whether this model is going to be a segmented model, or is this model going to be an unsegmented model. So that is the first question that we have to address, right? So let's say so let this be, your figure one. Let me put it over here. Now I'm creating a fresh tree, which is like your okay. So the first thing that we have over here is, let me give you this part. The first thing that we talk about over here is the known good bad models, right? The known good bad models. So for the known good bad models, the first question that we have to answer over here is that those models will be whether the model has to be a segmented model or is it an unsegmented model. So these are the first two questions. Now, how do you decide that whether you are to develop a segmented model or an unsegmented model? How would you decide? A segmented known good bad model and an unsegmented good bad model. Known good bad model. So out of these two models, how do you decide that which is the one that you should choose? What are the metrics? What are the parameters that you need to look into to decide like which is the one that you must choose? Yes. How do you decide that which is the model that how do you decide whether a segmented model needs to be developed? How do you
If the population is heterogeneous,
how do you know that? So basically,
univariate,
let's say the population is heterogeneous, right? But the business tells me no, you have to develop an unsegmented model. So how should I actually convince the business that I need to develop a segmented model and not an unsegmented model?
the bad rate of two populations should be significantly different, and we can check univariate analysis too.
Yes, but that is all for my confirmation. But how will the business agree to the fact that I need to develop a segmented model? Because think about it from the business perspective. The business has to implement two separate models in the two or more separate models in the system, right? And if they do that, they have to maintain and they'll have to have time and dedicate time and resources towards that. So when will the business be willing to do that?
When the adverse selection is reduced.
Yes, but how do you identify? So basically, the way we identify it is that if if there are the overall, yeah, tell me.
No, if the segmented model gives a better lift, so that will come to know in the after doing the
In
validation.
terms of what? In terms of what?
What we will do, Ginny, here.
Right. So there are several matrices in terms of which the segmented model must give you a better lift compared to the unsegmented model. So for example, so one of the matrices is Gini. So if after doing an segmented model, if I get, let's say a 2%, say some percentage lift, right? Let's say the Gini without the model is 45%, and I mean without segment 45%, and with segmentation is 48%. So you get a 3% extra lift in Gini, right? So that's there's an extra discriminatory capacity. So that's one field. Now the second field is there must be that the segmented model must be relatively more accurate than the unsegmented model. That is so if I divide the actual and predicted scores into score D size, then across each D size the segmented model must give me a greater extent of accuracy. Third is the rank ordering. Rank ordering must be better in the segmented model than the unsegmented model. Right now, given these three characteristics, you can justify that a segmented model is performing better than the unsegmented model. But that's where the business comes and tells me that what if I take a for a 3% less gene, what is the problem given that rank ordering is holding in that model as well? So then what you need to show them is in terms of business impact that the segmented, when you are developing a segmented KGB model and using that segmented model to develop your reject inference, right? Number one, the bias in the reject inferencing model is reduced. That's one. The second is when you're using that segmented reject inferencing model to score your good bad, and then from there what you are trying to do is you building the AGB model. So that AGB model is giving you a better lift, right? So when you go ahead to build the model, so over here, how many models are you getting right at the outset? You are getting two. You are getting at least two KGB model to be built up, right? So first level is you have your overall accepts versus marginal accepts. In the overall accepts, you go to build the known good bad model. Now when you go to build the known good bad model, what you get to see is that there is an unsegmented known good bad model, so which is one of them. Now there is a segmented good bad model, right? The number of segments you create, the number of segments you have is the number of or so number of models that you have. So basically if you finalize with two segments, right, then you have to build the two segmented model and one unsegmented model, so that's three models. So like this, the number of models will kind of increase, right? So so once you decide to go with a segmented model, what is the next question that you need to answer? How many segments? Or the next question is that what are the segmentation variables? On what basis, what variables will you be yeah, so basis what variables will you be creating your segments? So what are the candidate segmentation variables? So this is where you need to the next question that comes out here is, what are the key segmentation variables? On what basis can you create the segments? So let's say you choose 4 candidate segmentation variables. Then you first need to see that which is the best segment, right? And then based on the segment, or you need to identify that how is it, so which is the best possible segment, and based on that segment you need to develop the Gini, the case, rank ordering and everything. And then for the unsegmented model you need to do the same. And then what you do is you run the then you do the comparison and you choose whether your model is to be segmented or unsegmented. Now the approach that you decide over here, that yes, a segmented model is going fine, so that approach will be followed in the reject inferencing as well. And then you complete your reject inferencing. After you add back the accepted base, the rejected base to the accepted base, and you create your augmented good bad base, the same question again appears: do we need to develop a segmented model, or or do we not need a segmented model? How does it go about? So there again you have to decide on the segmentation and what each of the variables should go through, right? So at each stage there will be multiple models which will be built, right? So there will be multiple models which should be built and comparison done. And based on that comparison, what we need to do is we need to decide which is the best model that should move from here to the next step, right? So that is precisely the way of developing models in the industry. So at each stage, each question that we ask, we are going to try out multiple models, right, with multiple cases, and we got to summarize them at the development level, at the validation level, right? Now, for the augmentation data, so augmented data, we need to do the summarization at the accepts level, rejects level, accept plus rejects level. And for accepts, we need to do it at a validation, at a development and validation, development, validation, development and validation. So that's the way we need to do it. And at each stage, we need to look into how is it that the case and the Gini are varying together. So there will be a lot of, so we need to iterate, a lot of iterative activities which will be going out over here to create the final state of the models, right? And at each stage we will be asking the questions that which is the best model and what are the parameters of deciding the best models, right? But what remains constant throughout this journey is the method that we follow to develop the models, right? Now these models that we develop, right, will be called the, so these models will basically be your toy models, right? So we will not apply too much of variable selection, variable reduction and things like that, because the number of variables is very small over here. We will just apply a few basic filters. We will apply a filter on the VIF, the multicollinearity, ambiguity signs, and the post modeling one. So IV, weight of evidence and all, we will do when we have finally chosen the model that we want to develop, right? So with each of the models that we develop, we will have, so we'll first develop certain toy models to get an idea of which is the best approach to be taken. And then what we'll do is we'll go ahead and develop the final set of models. So let's say the segmented model becomes the better model, right, compared to the unsegmented model. So we go ahead and when we build the segmented models for each of the segments, that's where we'll talk about information value, weight of evidence, clustering, you know, and other measures like correlation, and then we'll see how it behaves on out of time and so on. So those are different issues that we'll consider. But when we are deciding, when we are researching on which is that best possible model to be developed, that's where we'll be using simple toy models, right? Clear on this? So over here we need to understand what are the key segmentation variables. Now, when I talk about key segmentation variables, what are the now how would you know, right, that I need to do a segmentation, and that a model is not, I mean, an unsegmented model is, or that I can actually think of breaking the data into two or more parts. How do we know that, or what are the checks that we identify on the segmentation variable? Any ideas? Now, one of the check I know is, that's a very common check that we call is the bad rate, right? So basically, if we see that the bad rate is different across the two categories, we say that yes, there is a difference in the segment's bad rate. That is something that I know. Now, any checks apart from that?
Hello, sir.
Tanmay,
Yes.
I am getting confused with this diagram and that EF. Can you this under? It seems like under overall accepts approach. I mean the base for developing the KGB model is overall accepts. That is fine. Now again, RI.
Overall accept, no. Overall accepts is not the base. That is the approach, Devusmi. So overall accepts approach is that approach where you are not weighting the accepted base with the marginal weights. So that's the approach. And marginal accept approach is the other. Now, when you are developed, so for the overall accepts approach, you have your accepted base. On that base, you are developing your KGB model. But when you are developing the KGB model, you are not using the marginal weights in this particular data, right? So on that accepted base, you are developing the known good bad model. So the base of a known good bad model is the accepted base. Then you are doing the reject inferencing. When you are doing the reject inferencing, so over there, it is a rejected base on which you are running the model that you have developed in step 1. And you are scoring the rejected accounts. So the base of the population remains the same. These are two alternate approaches. In the marginal accepts approach, you are weighting the accept by that marginal weight. In the overall accepts approach, we are not doing any such weightages.
Okay.
So it is not that base of the records, it is that approach.
Okay.
Is this clear to you?
Yeah, understood. No, actually, okay, no, I think now it is okay. No, I thought like KGB model on the overall accepts and reject inferencing on the accepts plus rejected base, reject. Okay, so no, this is the so there I got
So under
confused.
this approach, these are the 3 steps. If you do the marginal accepts approach, you will again do these 3 steps.
Understood. Okay.
Right? So when I say the overall accepts approach means I am just considering the overall accepts. So I'm not weighting any of those accepts by the marginal numbers. Now, in the marginal accepts approach, what I am doing is I am weighting each of the records by the marginal accepts such that the marginal at the records at the margin get the highest weightage corresponding to the best possible, the best profiles. So the importance of the best profiles are minimized and the importance of this profile is maximized. So that is what we are trying to do. That is what we are trying to do over here.
Understood. Yeah.
Right? Okay, so is this clear to everyone?
Tanmay, is this on any particular portfolio like this application scorecard build, or how is it not specific to any particular portfolio?
No, no.
This
This
data?
is the methodology, right? This is a proposed methodology.
No, no, not this one. I'm just asking like the one will do the develop this application scorecard on this German data set. Is it? I don't know the data, so I'm just like
Yeah, so
it's not.
it's a specific type of a portfolio, right? It's a point of sales financing portfolio.
Point of sales, what?
It's a point of sales financing portfolio. So a portfolio like Bajaj FinServ and these guys who sit at the point, and at the point of sales they finance your product. So if you go to buy a mobile phone or an AC, there are these financing guys, right, from Bajaj FinServ, from HDFC, who immediately help you with the credit. So it is this kind of a portfolio.
Okay, understood.
So Tanmay, is
Right.
it like personal loan or I mean the
The
authoritarian
product is
person?
loans. The product is loans. The way the transaction type is a loans transaction, but the portfolio that you have is not a typical personal loans portfolio. It is a point of sales financing portfolio. So the nature of the products over there is it's varied, right? And and there are different categories that we generally look into. So for loans, generally loans, personal loans are treated as personal loans. Now over here you take the loan, or there's a loan on automobiles. There are loans are given on your education, and then you have loans being given on consumer goods. So it's not a typical, it's not a typical this thing. It's not a typical personal loans, but it's a point of sales financing. So it finances whole different range of products. So the product type itself adds an element of heterogeneity or a risk to this case, because the personal loans will never be having automobile loans, right? So it will always be unsecured. Auto loans are a different kind of loans. So it is only in a point of sales financing portfolio which finances for everything. Will you have retail, you will have motor, you will have others, and so on. So it's that kind of a portfolio that we have over here in this data set.
Okay.
Right. So over there we look into key segmentation variables, right? And the number, and the more the number of segmentation variables are, or the candidate segmentation variables are, the more will be the number of variable. The more will be the number of the models that we kind of need to develop. But all these models will be essentially toy models, right? So let's kind of keep it till here. Let's not progress with this structure further, because that will kind of lead to a lot of confusion over here, right? So this is the known good bad model, and with the known good bad model, this is what the thing is. So let me just arrow over here. Now this arrow will help you better understand that. Right. So so this is where you're developing the known good bad model, and to develop the known good bad model, there is always a point of developing a segmented model, and unsegmented model, and a key segmentation. And So segmented variables, the question is, there are keys, we need to identify what are the key segmentation variables, and from here we need to decide whether it's a segmented model versus and kind of an unsegmented model that we are looking at. I'll put this versus. So over here you also have a segmented model versus an unsegmented model choice. So whether it's a segmented model versus unsegmented model, or that's the first thing that we need to do. So our first objective over here limits ourselves to this point, that whether it's a segmented model versus unsegmented model, and if it's a segmented versus unsegmented, how should the model look like? And once we get that unsegmented, we want to decide the set of models. How do we go ahead developing the model, right? So this is precisely the flow that you know that you get to see when you are working with an actual scorecard, right? Okay, so do one thing, look through this for a couple of minutes, see whether you get the flow, any questions, and then we'll move on to talk about the steps that we need to follow while we are developing the scorecards. Right? So then we'll start talking about that part.
Tanmay,
Yeah, Prabhu, tell me.
okay, now in the overall accepts approach and the already model in the production, like what's happening now, the sample would be the same, sample size would be the same, or like in the overall accepts,
No,
like there will
because
be a new.
no, the sample will not be the same, because the last model which was developed on an even older set of data points, right? Now the model that you are developing is
Okay.
being developed in terms of a more recent future point. So the scores which this particular account, this existing model has, the account which the existing model has scored has become your data set, has become your model base, right?
So just for an example sake, like to understand the process, you have for
Okay,
GTD.
so let's say, yeah, so let's say the last scorecard model was developed in 2016 or 15, right? So it used
Okay.
data before
Okay.
2015. So it used data from say 2013 and 14 to develop in 15. Now I am redeveloping the model in 2019. So what will I do? I will use the data from 28 2017 and 18 to develop 2019. Now 2017 and 18 acquisition data is that data which has been scored by the existing or by the model in production, right?
Right.
So the sample of the two models will always be different because there is no overlap, because the for business models the vintage of the data that we generally use is not generally more than 1 to 2 years of data.
Okay. So in that case, like let's say we are developing the scorecard now in 2019, like December we are developing it. The data would be from 2018 and 2019. So 2 years of data I'll be having.
For 2017 too, because see now standing today it is April, right? So the latest data I can use is till 2019 March, because that data will have 12 months of performance. Now April onwards 2019 data I cannot use, right? Because 2019 data that I will use will be the most recent months of performance. I mean, it will be the most recent OT. So it is only there that those accounts which are on the books of the bank, they will be scored with this speed, right? I mean, those applications which are coming in there will be scored. So the data, the last data month for modern development I can use is 2019-03. So after that, as of now, I cannot use any other data month. So the data that I will choose will perhaps be from say 2017, 2017-01.
Yeah. Okay, but those pop. Yeah. So got it. Now those samples would be scored using the current production model, wherein we will only use the sample which has been accepted.
Exactly. So you have the accepted decline flag for them. You don't know what was the score that was assigned to them. All you know is whether they were accepted or rejected.
Yeah.
Right.
And how yeah, got it. And how do I get 01 in the accepted model? Like if I want to get the
accounts which satisfy your bad definition in the next 12 months over your performance period will be flagged as bads.
Okay, I will look at the delinquencies then for those.
The delinquency trend will then define your bad definition, right?
Okay, got it.
Right. So, but for our purpose, for this purpose, we already have the 10 flag created, right? So what we are going to do over here is we are not going to create that 10 flag over here. So the 10 flag creation exercise, how we do that, will be seen when we develop the behavior scorecard model.
No, I just wanted to understand on the conceptual side. That's fine. So the 01 is already in the data that has been done.
Correct.
But that 01 would be based on the performance of all those through the door which happened from 2007 to 01.
No, this is only for the accepted. This is only for the accepted.
Yeah, accepted,
only
right.
for the accepted accounts that you have the 1 and 0s, right?
Okay.
For the rejected base, you don't have the 1 and 0.
Yeah, the accepted ones which came on books.
Yeah.
Yeah, sorry.
So for them, you have the 1 and 0s, right?
Right. So the accepted ones which have 0 and 1s came on books from 2017-01.
Right. So 2017-01 and there, right?
Yeah, till March 2019, which have 12 months of performance data.
Correct.
Okay.
Right.
And one more question, Tanmay. So
yeah,
the snapshots which we create, the snapshots would be monthly, or snapshots will be like quarterly. So like the applications which come on books
for
each
acquisition
month,
models, we don't do anything like that. So for acquisition models, we don't do anything like that, because the data is new every month, right? So every month new accounts are there. So whatever information you have, you take it as a whole. But for some months you keep aside as your model, as your out of time validation, and some you keep for your model development and like in sample validation.
So it will not be like monthly snapshots. It will
No,
be like
that
one period
happens for
data.
behavior scorecards. That happens for
Oh,
behavior scorecards because you have multiple accounts occurring at different months, right?
mm,
But for an acquisition model,
okay.
every month, if you look into the data, they are new data sets.
Mm,
I mean, they are new accounts, right?
okay. 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 So then there'll not be there all will be unique then. Like all accounts will be unique.
Yeah. So if I applied for a loan this month and I'm accepted on the books, I move on to the books of the bank, right? Now next month, someone else will come and apply. I'll not again apply for the loan. So I am not saying that they don't repeat, but I mean, it's
Yeah.
highly likely
The
that they
chances
will
are
not repeat,
very low.
right? Because every now and then I don't take a loan. Because if I'm doing that, then there is something wrong in my profile,
Yeah.
right?
Thanks.
Okay, great. Fine. So just take 2 minutes time, go through this. Let's take a 2-3 minutes break, and then we'll again start off with the scorecard development exercise.
This conference will now be recorded.
Okay. Okay, fine. So, so the following are the important steps of developing a scorecard. So what are they? I'll just reduce the zoom percentage over here. Fine. So the first and the most important step of any model development, right? Before a model development process initiates, is the scope analysis or the scope and the gap analysis. Now, for some case, it's the scope analysis. For some, it's the gap analysis, right? The second important step that we have over here is identification of the dependent variable and the key independent variables. So over here, what we need to understand is that so basically what the first thing that we need to understand here is the identify that how is it that the dependent variable and the key independent variables are to be identified? How is it that they are to be understood, right? Now, the second thing that we talk about over here is the data extraction and the source to target mapping. So once you've identified your dependent variable and your key independent variables, so now the next part is you are extracting the information on all and multiple variables from the data. You are extracting the golden level data and so on. You have this data extraction and source to target mapping exercise. Now, in this data extraction and source to target mapping, the what we are trying to do is we are trying to extract the data from different sources, and because I'm extracting the data from a raw warehouse and I'm trying to use this in this particular and I'm using it as a front end variable, right? So basically there was a raw data source and there is a prepared data source. So it is very important that the data from the source and the target data set is kind of reconciled. This is absolutely important to ensure that the key variables that we have are or they have kind of been reconciled in a way, right? In a way that it helps you explain the key characteristic stability or that to ensure that the variables that we are working with are properly populated. So that's one. The second thing that we are kind of talking about over here is the data quality check. Now, once all your variables are extracted, you know what your dependent variable is, you know what your independent variables are. Now, what you are doing is you are doing a data quality check. So over here, you are trying to assess the characteristic behavior of all your variables. You are trying to assess that how is it that all the key variables of your model are behaving. Is there an abnormal trend observed or abnormal spike observed in the long run trend of your key descriptive variables? Is there a long run check that you have, right? So this is something that we need to understand. Right? So after we have looked into the data quality check, the second set of the second set that we have is the next step that we have is the variable selection exercise. Now, in the variable selection exercise, what we are trying to do is we are trying to reduce the size of the total number of variables that we have in the data, right? And we are trying to filter them out such that we are in a better position to work with them. So so we are in a position where we could actually work with the overall characteristic behavior of so overall with those variables which are kind of so with those variables which are kind of predictive in nature, right? The variables which are very highly predictive in nature. So we have a part of that. The next that we have over here is the model development exercise, right? Now, after you have selected all your variables, so first what you do is you assess the data is structurally correct. Then you see that the data is behaviorally correct. Now you see that the data is only those variables are selected which are structurally correct, which are behaviorally correct, and which have a high predictive capability. So after the variable selection step, we stand at that part. Now we try to run we go towards the model development part, where we are running the logistic regression equation. We are looking into the descriptive measures. We are trying to assess the goodness of fit of the model, and we are trying to ensure that the model developed is uh, is a good model or not, and how is it that we can validate the model. So these are some of the important questions that we need to address, right? Now, once the development exercise has happened, the next thing that we'll talk about over here is the model validation. Now, 6 and 7 go hand in hand, right? So once the model is developed, a validation exercise is simultaneously conducted, right? And once the variable selection exercise is completed, then what happens is the final state is the model implementation and documentation. Now, in interviews, there is a question which comes up that what are the key steps of developing the model, right? And this is the part I've been talking with some of you in this forum as well. That if someone asks you this question, you need not worry about the entire end-to-end model development process. All you need to tell them are these 8 steps and a summary of these steps, and what exactly is done in the step, and what exactly are the analyses which are performed in the step, right? And when we talk about the analysis performed, so then obviously there will be a certain set of deliverables which must be there, right? So what are the key outcomes of each of these analyses? That is what you need to discuss, or this is That is what you need to describe it in this forum, right? So this table that I have created precisely is the answer to that question. The video recordings corresponding to this description is there in the Google Drive that you have, right? So it's within the application scorecard folder. There is a second folder in the video recordings which says steps of developing a scorecard. So you must know. So over there, there's a detailed description with whiteboard works and everything stating how exactly is it that a scorecard should be developed. That how is it exactly that a scorecard should be developed end to end. Clear?
Then we won't be doing variable exclusion from the
Sorry.
initial. We won't
So
be doing exclusion here.
yeah, variable. So, but in this particular case study, we would not be doing a variable exclusion because the number of variables that I have in the German bank data is only around 30 or 31. So a majority of the variable will be removed as a part of the other variable selection exercises. But yes, in the real-time exercise, we do variable exclusions. Now, the variable exclusion, as far as the exclusion exercise goes, it is a part of the data quality check procedure, right? Or you can say the initial part of reductions. So I have discussed this variable exclusion under the data quality check exercise. But generally, you do variable exclusion right at the beginning,
Yes. Hmm.
right? No, you don't generally do variable exclusions often at the beginning, though. You do it at a, sorry, you do the observation exclusions right at the beginning, but mostly the variable exclusions is a part of the data quality check. Now, yes, you can do it at any like, and when the initial parts, they will not kind of stop you, but mostly I keep it club it with the data quality check part.
So, but like
Yeah,
when the variables which won't be explaining any part of the credit risk. I mean, as you have told in your videos that the variables explaining
yeah.
operational
So
risk.
basically, exactly. So if you have any growth unnecessary variables right at the beginning, and it's very explicitly unnecessary, just remove it right at the beginning. But generally what happens is that when you are actually extracting, so think about the code, right? That the way we write it. So there's a list of variable that we specify that needs to be extracted, right? So what happens is it is very difficult for you to identify those variables while you're writing the code, because the practice over here is that you take that list from someone who has given you put that and you extract everything. So when you are extracting, you extract just everything, the dump, right? So after you have done that dump, then what you do is you do the variable exclusions, right? Then you do your first occurrence, last occurrence analysis and whatever. So that step can be done at any possible part. So I have kind of documented it with the data quality check because of the fact that it is a part where the unnecessary variables are being excluded. But you can do it as well as even before you are kind of, doing the data quality check, the source to target mapping, because unnecessarily you would need to do it for everything. Now, generally, again, source to target mapping is done for very specific variables, not for everything that we have seen, right? So you can just do it at any point of time. It's hardly going to matter, because when you are trying to define your dependent variable, they are not going to come in. When you are extracting them, they may get extracted, but then you just remove them. After source target mapping, the next step is data quality check, and you just remove that, right? Now, see, these steps are kind of written in order in which I generally tend to execute them. Now, it doesn't mean that the data quality check cannot be done first and then the social target mapping cannot be done. So it may be it may come out as a way, you do a quality check exercise and you see some issues in the key variables. Then you go back and you do a social target mapping, reconciliation, account to account reconciliation, and you check whether everything is absolutely correct or not, or where exactly is the issue that it is rising, where exactly is it that the issue is arising. So that is the part that we kind of tend to talk about. So this is so these steps are just in an order in which I generally tend to frame them. This is not a hard coded series of steps. They can always change orders
Mm-hmm.
depending
So,
on the situation on which you are developing the model, depending on the set of other ancillary conditions. Yes, Srija, tell me.
so in the second case study, or I mean the third one, are we going to perform this variable exclusion anywhere in the entire?
So for this data set, no, we are not going to perform the variable exclusion. That variable exclusion exercise is generally performed, or for my case study, for the data that we have, we do a full-fledged variable exclusion when we are doing the the lending club data. But here, yes, there are a few small cases of variable reduction because we have there is an active variable waterfall over here, right? That each state some variables are getting removed for some issue or the other. It's not because of the fact that they are not relevant to the model development, but it is because the variables are not intuitive to the bad rate situations that is there. So those are characteristic issues with the variables. So on account of those, the variables get removed. So you will have a full-fledged variable exclusion exercise even in the German bank data as well, right? But that specific exclusion that you are talking about, that removing the redundant variables, that specific exclusion will not be very actively seen in this case, apart from one or two variables, because mostly these variables, the way these variables are structured, it's a set of relevant variables.
Mhm. In the lending club data, we'll be doing that, right?
Yeah, in the lending club data, we have already done that, right? So during the Basel sessions that we had, so when we did the model design, when we did the data preparation, we did a full-fledged variable exclusion over there. So you remember
Actually,
that Basel results summary, the data dictionary tab that we had over
I was going through the Basel data preparation, I mean, videos yesterday. So I couldn't find the step is just, you just mentioned this step, but I couldn't see any exercise happening on that. I mean,
there.
I
What
could
are
see
you
the,
saying, Anita? We spent 2 full classes on that.
so it might not be there in the folder, or maybe I'll have to
No,
revisit them.
everything is there. As far as that data exclusion and that waterfall is concerned, everything is there.
Okay, I'll just
Maybe in
revisit
that particular video that you saw, maybe it is not explained there, but there's a full-fledged coding exercise following that, where
it.
the thing is coded and the variables come out, missing observations are detected,
Yes, yes, yes.
100% missing values are detected for some variables and they are removed from there. So
Yeah.
it is for the lending club data, that entire exercise is done over 2 classes, if I'm not mistaken.
So this missing observation thing is done, but like you said, the variables which are explaining the operational and the market risk parameters, and the ones which are not, having the explanation capability, so those are removed. I couldn't see any exercise happening on that. So might be I'll just revisit. I'll just let you know if I can't find that
So
in the
maybe
particular.
you have skipped out or missed out something, but those exercise, I mean, the variable exclusion was there is at done at multiple levels for the Basel result for the Basel data.
Okay, okay, then I'll just revisit and
So
check.
you might have missed out something in the classes, but those were done. So were you looking into the videos that were there in my drives, or
Yes,
were you
yes.
looking into your class videos, which was
No,
that
no,
you
no.
were?
The ones which you have put in the drive.
Yeah, so then it is definitely there.
Okay, okay. Let me revisit.
Yeah. Okay. Okay. Fine. Fair enough. So our next step will be to take up each of these steps, right, and kind of try to analyze what exactly are the functions that we are performing here, right? What exactly is done in this step? What are the analyses that we are performing here? And at the end of each steps, right? What are the key deliverables that we have? So what are the key results, or what are the key outcomes of each of the analyses, right? And then on a stepwise basis, we need to update them, right? So so this is something that we do in tomorrow's discussion. So just before tomorrow's class, right, you have this Excel sheet with you. Just run through this Excel sheet once, right? I will add further documentation, and after tomorrow I will share this latest updated version, because I will be making certain changes to this, certain addition to this document. So tomorrow, after tomorrow's class, I will share this. But the Excel sheet that you have with you in the drives, you will have this entire table up there, right? So just go through this table, right? Just go through this table. Just see through this thing. I will explain that, right? And then we'll start off with the coding exercises, right? So So we meet tomorrow. Tomorrow we'll be completing this table, and then onwards we'll start off with the codes. And whatever concept you need to refer to, you can refer to it in the worksheet tab. So the worksheet tab has all this concept of seasoning analysis, roll rate analysis, performance margin, data extraction, type of variable, source to target mapping, right? Quality check procedures, missing values, and so on. So all key concepts required is up here in this Excel sheet, right? So just go through this tomorrow for tomorrow's discussion. Tomorrow we meet, we'll complete this table, and the next class onwards, we'll start on with the modeling exercise hands-on. Right? Okay, so thank you guys. Thank you for your time today, right? Let's catch up. Let's finish this part and let's take the show up from there. Thank you. Bye bye. Have a great day tomorrow. Bye bye.